All right, this is the last of the chi-squared, and this is the famous Choco Zutie ones. That was they accepted it at full credit back in 2016 as a test of independence, but it is not. It's a chi-square test of homogeneity, and I'm confident that if you ran it as a test of independence now, you would not get full credit. That you, I don't know if you'd get 3 points or 2 points if you did everything right. So please make sure that we recognize the difference between chi-square test of homogeneity and independence. Remember, chi-square test of independence is one sample with two variables. Homogeneity is either an experiment or multiple samples. All right, either an experiment or multiple samples. So product advertisers studied the effects of television ads on children's choices for two new snacks. The advertisers uses two 30-second television ads in an experiment. One ad was for a new sugary snack called Choco Zuties, and the other ad was for a healthy snack called Apple Zuties. For the experiment, 75 children were randomly assigned to one of three groups, A, B, or C. Each child individually watched a 30-minute television program that was interrupted for 5 minutes of advertising. Okay, so the advertising for group A, so basically, we had 75 children who were assigned to one of three groups. This is what's important. I have a matrix, and as soon as I have a matrix and I say, oh, we have an experiment, then I know it's homogeneity. After the program, the children were offered a choice between the two snacks, the table below. Do the data provide convincing evidence that there is an association between the type of ad and choice of snack among all similar to those, among all children similar to those who participated in the experiment? So they're saying, hey, can we generalize to children who are similar to those in the experiment? And basically, they just need to know whether it's statistically significant. Well, right here is my matrix, and I say, oh, it's 3 by 2 because it's rows times column. And remember, rows minus 1 times columns minus 1 gives me my degrees of freedom. So 3 minus 1 times 2 minus 1. So 2 times 1, so my degrees of freedom in this case are 2. So I'm going to pause for a moment and enter this in the matrix. All right, so with the chi-square test of homogeneity, we need to talk about the proportion. So the proportion of children who would choose each snack is the same. So in other words, we like that positive, we like that equal sign. And the proportion of children who choose differs or is not the same, depending on which ad was shown. All children were randomly assigned. This was given. This is why this is a test of homogeneity. This also tells me this is an experiment, which means we can show causation. Because it's an experiment, we do not do the n is less than 10% rule. We don't have to do the n is less than 10% because it's an experiment. So I need to check those expected values. So here's what I did. I go second matrix. I go into edit. We already said it was a 1, 2, 3, 3 by 2. So 3 enter, 2 enter. And remember, my expected values have to be greater than, oops. I went to the wrong place. So second matrix, edit. There we go. 3 enter, 2 enter. So I've got my data entered in there. Looks like I have it entered incorrectly. That should be a 21. I better put my glasses on so I can see what I have. I have 21, I have 4, I have 13, 12, 22, and 3. So that's right. So I have all my data entered correctly. Now I'll have a lot of students who will say, hey, that's a 4 and that's a 3, and they're supposed to be greater than 5. And it's like, we don't care about the observed values. The observed values can be 0. The observed values have to be whole numbers, but as long as they're whole numbers, we don't care if they're less than if they're less than 5. We only care about the expected values. As long as the expected values are 5 or greater, we're good to go. So stat, test, chi-squared test. We're just going to run this thing. and write down our important information. So we get a chi-squared value of 10.29. And we get a small p-value of 0.0058, which is less than alpha, so we're going to reject. But I need to go back and get and verify that I can actually run this test. Are these actually correct? So second matrix, arrow over to edit, and drop down to B, and sure enough, 18.6, 18.7, and 6.3 are all greater than 5. So all expected values are greater than 5. So that's taken care of. So we can go ahead and run this, which we did. And I went ahead and showed each one. 21 minus 18.7, 13 minus 18.7, 22 minus 18.7, 4 minus 6.3, etc. So that gave me these values if I solved them independently. And please note, these are my contributions. Those all sum up to my contributions, and my contributions sum up to 10.129. So our p-value is 0.0058. We reject the null. There's sufficient evidence that alpha equal 0.05 to suggest that the proportion of children who choose a snack differs depending on which ad is shown. The ad does appear to impact what snack. Although the Choco Zuties ad produced results, so part B, write a few sentences describing the effect of each ad on the children's choice. Well, I'll probably need to look up here. So here, Choco Zuties only, we overperformed. All right. Apple Zuties only, we underperformed. So if we chose Apple Zuties only, we didn't buy the Choco. But if we showed neither, we bought the Choco. Matter of fact, we had more people buying Choco who watched neither ad than those who bought it after watching the Choco ad. Over here, if we didn't watch, number who chose Apple Zuties, that was less, so that underperformed. If I show the Apple Zuties ads, that way overperforms. That appears to overperform by the most. And if I show neither ad, we don't buy, we underperform. So it seems like the Apple Zutie ad and the Choco Zuties ad are pretty successful, but it seems like this one is a lot more successful because this is only slightly up and this is substantially up. This is almost up by double. So the Apple Zuties ad, well, although the Choco Zuties ad produced results greater than expected, 21 versus 18.7, the impact was less than the group that were shown neither ad. That's bad. So it doesn't appear to me that the Choco Zuties ad was very impactful. And here's what we're saying. 21 who watched the ad bought it here. If they didn't watch either, they still bought it. All right, almost the same. The Apple Zuties ad produced the highest chi-squared value of 5.16 and appears successful in persuading children who seem to have a predisposition to Choco Zuties ad to choose the Apple Zuties ad as the actual was 12 out of 25 versus the expected 4 out of 25. The Apple Zuties ad appears to have been successful. So Apple Zuties ad, yay, that looks like that worked. The Choco Zuties ad, go back and do some more work. All right, and that concludes chi-squared tests, and now all we have left is regression.